Welcome back.
Hi everybody, welcome back. We're ready for day 4-7 rather, inverse trig functions, and if you paid any attention last class at all, this should be easy.
We're ready. You should be ready anyway, hopefully.
It should be easy.
Why don't you summarize what they were supposed to get out of last class?
Okay, here's what you were supposed to learn last class. On an inverse sign, we can write it as a sine inverse, we can write it as an arc sine. You should have figured out that we had to restrict our domain, so it's only this little bit of the curve right there. It's been flipped because it's an inverse. Notice that the domain is from -1 to 1, and the range is are the angles rather. These are your angles, and they're from -pi/2 to pi/2. Now, if we think about this in terms of our unit circle, where is pi/2?
Quadrant 1.
Quadrant 1, and where is -pi/2?
We go down to quadrant 4.
Okay, so our possible answers are these two quadrants, these two directions. You're not going to worry anything at all about over here. Okay, I like to call it the right side. I can't help myself. Okay, he's laughing at me, don't worry. All right, what if it's an inverse cosine? Again, we've got the same notation, cosine inverse or arc cosine, but this time notice our range is a little bit different. This time we're really going from the x-axis up to pi. So when we look at our unit circle, where's pi?
Pi's at the 180-degree mark.
Exactly, so we can use any of the top of the circle, the unit circle that is, this is 0, but none of the bottom. All of our answers will then be, what kind of angles make us go across here?
Positive.
Positive answers. They will all be positive answers, okay? So
is that the top side?
yeah, I just call it the top. I like top side. Let's go with it. Okay, what if we have an inverse tangent? Same thing, same notation. The only thing that's different is we have our parentheses instead of brackets. Now, why is that? Well, if we look at tangent on the unit circle again, here's our pi/2, here's our -pi/2, and we can go this way and we can go that way, but what happens when we hit the y-axis?
Tangent's undefined at pi/2 and -pi/2.
Okay, so we cannot include the y-axis, okay? We cannot include this side either. So it's also the
right side.
Okay. All right, you know you want to be us. Okay, first question, let's do an example here. We remember that an inverse finds an angle. So you're really asking yourself, find the angle whose cosine is 0. So where it's a cosine gets to be on the top, so not down here. Where on the top is the cosine or the x value 0? Right there. That's the only point where we have 0 comma something so that our x value is 0. Okay? What's the angle that got us there?
Pi/2.
Pi/2 is your answer. That's it. Ta-da.
That was easy.
That was easy. Okay, let's look at the sine inverse. Sine inverse. So let's think about our restriction. Where's sine inverse get to live?
Right side.
Right side. Yep. Sine inverse could be over here, but not over there. Okay. Where sine is x or y on the coordinates?
On the unit circle, sine is the y value.
Sine is the y value. He said that so much better than I did. So which dot on the unit circle is going to give us a sine of y being a 0?
Well, how about the one on the x-axis?
How about the one on the x-axis? 1 comma 0 has a 0 y value, so the angle is
0.
0. Okay? So those two are pretty easy. Those are our quadrantal angles. What if we don't have a quadrantal angle? Well, let's take a look right here at our arc sine. So again, we're going to live over here on this side and not over here. And notice that this is positive. Since I'm asking what angle creates a positive sign, I have to be talking about the first quadrant. There must be some sort of little triangle over here and some little angle right here. Maybe they're happy little angles like the painter man.
So if it was a -1/√2, would you be in quadrant 4?
Exactly.
Cool.
Okay, so this plus or minus that we don't write is really important right there. You have to pay attention to what you're asking, okay, or what the question is asking rather. Okay, so now we have a triangle here. Sine is opposite over
hypotenuse.
So that would give us a 1/√2, which means this is also a 1 because of our little triangles. Or you can use the chart. Mr. Leckie will show that in a second. So if you're using that little triangle, it's a right triangle. Two sides are the same. Theta must be
45 or pi/4.
Or pi/4. So the arc sine is in the first quadrant. The reference angle and the angle are the same in the first quadrant. Our answer is just pi/4.
Ta-da!
Ta-da! Okay, last one. Arctangent of 1. Okay, tangent's a little bit funky. Remember, tangent is sine over cosine or y over x. Tangent also lives They're on the right side, and this is a positive 1. So again, we are in the
First quadrant.
first quadrant. I need a triangle whose angle makes me have my y over my x, or my opposite over my adjacent, equal to 1.
So 1 over 1.
So 1 over 1 is 1. This must be a root 2. Again, I'm talking about a 45, 45, 90 right triangle. Again, my answer is
Pi over
pi
4.
over 4. I'm out of room up there, so I'm going to write it down here. Ta-da. Remember, you are giving angle answers, and I believe we're giving all radian angle answers.
All radian angles is our goal.
All radian angles, okay? So let's see if they get a little bit harder, and let's take a look at our table. Come on, Mr. Lecky.
All right. So
Yeah,
just
yeah.
to have a different perspective and how to look at these numbers, maybe you like drawing triangles, maybe you like looking at the chart. Really, we don't care.
We don't care.
We care that you get the right answer, and that's all we care about, all right? As long as you're not cheating, everything else is open, okay? So here's the deal. We're trying to do cosine inverse of 1/2. And again, 1/2 is a numeric ratio. We're trying to find what angle it came from, okay? So you can do this by drawing the triangles, or you can take our table of sine, cosine, tangent here, and 30, 45, 60 from before, and just look for where the cosine is equal to 1/2, and we look at it and we say, hey, it's 60 degrees. Now, you might want to remember that 60 degrees is what in radian measurements?
Pi over 3.
It's pi over 3. So since cosine of this was a cosine of a positive 1/2, we are in quadrant 1, and so we're just going to have a pi over 3 reference angle in quadrant 1, which is pi over 3.
So we still have to consider the quadrants, but we can just use the chart.
We consider the quadrant, we use the chart right off we just read it right out of the chart.
Okay,
All right?
that was easy.
How about tangent inverse of negative square root of 3? Well, if we're at negative square root of 3, the negative sign tells us we're no longer in quadrant 1. What quadrant is the tangent negative in?
Well, it was the right side, so that must be the bottom
So we'll
quadrant
use your
4.
picture. We're down here in quadrant 4, correct?
Okay,
All right, so we know that our angle is going to be negative
correct.
because
it
we're
has
simply
to be.
going down.
Correct.
So all we have to do then is read our chart. Where does the square root of 3 show up? Well, here's the square root of 3, and that's also a 60-degree angle. So we're just going to go down 60 degrees or down negative pi over 3. And that's
I
all
think
we're
I got
doing.
it.
So if you're visual and you really need the picture, then draw the picture. If you like the numbers, just pull them right out of the table. Or combine the two of them. Draw yourself a picture and pull the numbers out of the table. Again,
Exactly.
doesn't matter to us at all.
As long as you
Okay?
get them right,
Yes.
we don't care.
That is all that matters. Okay, negative square root of 3 over 2, we have arc sine. Again, the negative tells us that we are not in quadrant 1 anymore. So what quadrant is sine going to give us a negative answer in?
Quadrant 4.
So we have to go down an angle. And that angle will be, if we look at our table, sine was the square root of 3. Oh, look, weird, pi over 3 again. So
Who
this
made these examples?
I don't know, but they're all the same.
How
It's really
boring.
strange. Okay, but
Is
we
it
end
always
up-
this easy?
No, well, usually it's just they're not always the same answer. All right, let's try one that's, I don't know, a little different. So let's try this.
You ran out of colors.
I
didn't you?
ran out of colors. Let's go with highlighting. I've got a negative square root of 3 over 2 here. The negative for cosine, though, is the part that's going to be the only difficult part of this whole thing, really. Because where is cosine negative? Since we're not in quadrant 1, what quadrant will we be in?
Oh, we have to be on the top, so that must
Yep.
be quadrant 2.
So when we go to quadrant 2, we're going to pull our answer from our table, but that answer is going to be the reference angle.
The reference angle. Okay.
And we're going to have to adjust for our quadrant 2 answer. So
Okay.
let's do this first. We've got a quadrant 2 answer of square root of 3 over 2. So we go look at our chart, and square root of 3 over 2 for cosine comes from a 30-degree angle.
Pi over 6.
Pi over 6. So the answer is going to be pi over 6, and I'm going to go ahead and adopt the picture here. Pi over 6 is our reference angle. It's just this side.
Oh.
Our answer, though, has to be a quadrant 2 angle. So what angle did I use to get from here all the way to there if this was pi over 6?
Well, the denominator is a 6, so the pi would be 6 pi over 6. So back up a pi over 6. Is that 5 pi over 6?
That'll just be 5 pi over 6.
Oh, okay. So you can't just put a negative on it?
Nope. For sine and tangent, you're going to be able to put a negative on it because
Okay.
you're simply going down to quadrant 4.
Okay.
But for cosine, or for arc cosine or cosine inverse, you're going to have to adjust your answers that are in quadrant 2 based on that reference angle. And
And
once you
the-
get the hang of that, it's not real hard. But
And the table only gives you the reference angle.
the table's only going to give you the reference angle.
I got it.
All right, let's
Does it
keep
get
going.
harder?
Well, let's see. That's always up to you. We're going to do 2 at a time. If
Oh,
one thing's
no.
not that hard, doing it again, it's just longer, right?
Okay.
Is that all?
It's just longer. Okay,
Let's
we
find
can do
out.
this.
Okay. Composite functions with inverse functions. We're going to put one function inside another. We're either going to put an inverse inside of a regular function or a regular function inside of its inverse, okay? And we're going to mix them up. So how do we do this? First things first, we're just going to work from the inside out. That's all we're going to do. So if I have to find the sine of the arctan of negative square root of 3, I'm going to work on this part first. And I'm just going to find the sine of whatever arctan of square root of 3 is.
Okay.
Okay, so again, I'll do it my way. Since I'm doing this one, I'll do the next one your way. How's that? All right. Negative square root of 3, the negative tells me I'm in what quadrant for tangent?
Quadrant 4.
I got to go down to quadrant 4.
So it's a negative angle, I know that, right?
Negative answer. So why don't we just stick a negative there? How's that?
Okay.
Okay, the square root of 3, I go over here, look at my chart. There's the square root of 3. Again, it's 60 degrees. Go
Pi over
figure.
3.
By now, you should all know that that's pi over 3. And now we simply have to take the sine of negative pi over 3.
Okay.
Well, now we're back to the first half of chapter 4.
We did good on that.
We did good on that. Let's do this. Negative pi over 3 would have gone down pi over 3. We would have been in the fourth quadrant, but we knew that already. That's a pi over 3 reference angle.
Yes.
It's in the fourth quadrant. What is the sine of pi over 3? Well, again, I could pull that off of my table and just look at it. I get square root of 3 over 2.
But it's in the fourth quadrant, so is it negative?
Since it's in the fourth quadrant, we go back to our ASTC, which...
All students take classes.
There we go.
I'm sure that's what they're thinking.
That the sine is a negative answer. And there is our sine of our inverse tan of the negative square root of 3 is negative square root of 3 over 2.
Okay.
All right? One more time. Oops.
Wrong button.
All right? You want me to do this one?
Sure.
All right, I'll keep going. We have cosine of 5 pi over 3. Well, now we have the cosine inside, which is, again, our normal trig function. So we're going to find 5 pi over 3. What quadrant's that going to be in? Well, it's bigger than 180, so we're going to keep going. This would be 1.5 pi over 3, and this would be 4.5 pi over 3. So 5 pi over 3 is going to get me all the way around to quadrant 4.
Okay.
And what would the reference angle be then?
Pi over 3.
And we're just going to be really good at that angle before the day is over. Okay. Pi over 3. So the cosine of pi over 3 is 60 degrees, and the cosine of 60 degrees or pi over 3 is 1/2, right
Okay.
out of my table. So I'm going to take cosine inverse of 1/2.
Okay.
Now,
And
is it a
it's-
positive 1/2 or a negative 1/2?
Well, ASTC, we're in the C quadrant. It's positive.
Since we're in the cosine quadrant, this is a positive answer.
Okay.
Now, some of you may have seen this at the very beginning and said, well, if I'm taking the inverse of a function, don't they just cancel?
Yeah, don't they just cancel?
You would hope so. You would think so. But with trig functions, they have these limited domain and ranges.
Oh.
And so you have to be careful when you're doing these things in order. You can't just automatically assume that the inverse cosine cancels that cosine and get 5 pi over 3. That's not within the range of the inverse cosine function. So
Is that why we spent a whole day on domains and ranges?
that's just weird, isn't it? There's almost like there's a plan in place.
I think somebody knew that was going to happen.
All right? So now we basically have a new problem where we're starting over again. We're pulling the cosine inverse of 1/2. Well, since it's a positive 1/2, cosine is only defined in the top two.
So it's got to be the top one.
So we're in quadrant
Quadrant
1. And now we're looking for a reference angle or an angle that the cosine gave me 1/2. And I can go over here and pull that right out of my chart again, which happens to be 60 degrees, which, go figure, is pi over 3. You know they're going to make every answer on the entire planet pi over 3 when they get stuck.
Not
right?
after they do the worksheet. they
Okay,
won't.
good. All right. So, hopefully that'll make sense. Just make sure you do one step at a time. Now, we're going to switch it up a little bit, and instead of giving you angles, we're going to give you algebraic expressions.
Right.
All right? So you've got to figure out how to switch this trig expression into purely algebra, all right? Which is helpful for some things in calculus, just so you know. You're up.
Plus, it's just cool that the trig all goes away. Okay, there's me. I like the cool ones. Okay, so let's take a look. We need an algebraic expression, and all of the trig stuff is going to go away. Okay, so if we start from the outside in, because this is a composition again, if we start from the outside in, I need something for this cosine inverse of x. What does that mean? That means I have some angle that when I take the cosine of that angle, I just get x. Okay? So let's draw a little picture here. I'm just going to make a right triangle. And I'm going to assign my angle to be in this corner. It doesn't matter. Just pick one. Cosine is what ratio?
Adjacent over hypotenuse.
Okay, so the adjacent must be x, but this isn't a fraction, so I'm going to create a fraction by making x over 1. The adjacent side is x. The hypotenuse side is 1, so the cosine is x over 1. I don't actually know how big that angle is, but I know it's that big right there. Okay. We don't have to actually know a numeric value for it. What we do need to know is the third side of the triangle. So we're going to do a little Pythagorean theorem. Remember this third side, I'll call it b, is the variable. It looks a little weird at first because you're like, what am I solving for? There's two variables. No, no. We need to find the missing side, which is b. Okay? So we're going to go b squared equals 1 minus x squared. Just square them, take the square root. And the third side is actually the algebraic expression of 1 minus x squared. Okay? So if I'm fancy, can I take that and put it over here? Except for that it doesn't. It goes right there. Okay. So now that my triangle is complete, I can go back and say, what was I really asking for? I was asking for the sine of whatever that was, which was some angle. Okay? So I need the sine of the angle in this triangle. Okay, sine is opposite over hypotenuse. The opposite side was this algebraic expression I got, which was the square root of 1 minus x squared. And it's over 1, so my answer is square root of 1 minus x squared.
And there's no sine or cosine
No
in
sine
your
or
answer.
cosine. Ta-da!
Love it.
I just had to throw in the ta-da. It's kind of fun. That was a little weird. Let's try another one.
The ta-dum was a little weird too.
Does that matter?
I don't know.
I can't stop doing it.
It won't go away. It's just gonna have boxes and
It's
things.
going to have
around it.
boxes. Ignore the boxes. Ignore the man behind the mirror. Okay, so we have the sine of 2x this time. I'm sorry, the sine inverse of 2x. So there is some angle that when I take the sine of it, I get 2x, which means that there is a triangle. And me being the boring person I am, I'm going to put it in the exact same way. Only this time it's the sine that's 2x, and sine is
Opposite.
over.
Hypotenuse.
So it's 2x over 1. So now we're down here finding this missing side. I'll call it a. Okay, so a squared plus 2x squared. Be careful here, because 2x squared is not what you think it is. Okay? 2x squared is not, yeah.
2x squared.
2x squared.
It's 4x squared.
It's 4x squared. So this is going to be 1 minus 4x squared. Take the square root of both sides.
And we're singing now.
Yep. And that is our a value. Look, the arrow all fits. Okay, what were we really looking for? We were looking for the cotangent
Of that same angle?
angle. So the cotangent of that angle, cotangent, well, let's see, tangent is opposite over adjacent, so cotangent is adjacent over opposite. So I need my square root of 1 minus 4x squared
Over 2x.
over a 2x. It's not a very pretty expression, but hey, there's no trig in it.
None at all.
None at all. Okay, so we covered a simple inverse, we covered composition of inverse, and we covered an application of those composition of inverses. I think we're done.
Think that'll do it.
Are you going to say bye?
Well, bye-bye.
Bye.